Alright, so let's actually see how you're protecting yourself or your users against clickjacking. So once again, as we've seen in the previous video, clickjacking attacks trick web users into performing an action they did not intend, typically by rendering an invisible page element on top of the action the user thinks they are performing. Clickjacking won't affect your site directly, but it could potentially affect your users, and only you can actually protect them. Just want to make sure that I'm recording here. Alright, now what are the risks? So prevalence is not as prevalent as the rest of the attacks that we've seen previously, but the prevalence is occasional, exploitability is quite easy, and impact is harmful. What could a determined hacker do with a clickjacking attack? So in our example that we've seen in the previous video, the user was actually tricked into liking an item on Facebook. Actually, not necessarily liking, but sharing it. Clickjacking has also been used in the past. So what has it historically been used for? To harvest login credentials by rendering a fake login box on top of the real ones. So it has been used in combination with phishing. Trick users into turning on their webcam or microphone that's serious by rendering invisible elements over the Adobe Flash settings page. Now, modern browsers do have certain security mechanisms to actually prevent this to happen, but they can still be bypassed. Spread worms on social media sites like Twitter and MySpace. Promote online scams by tricking people into clicking on things they otherwise would not. Spread malware. So how do you protect against clickjacking? So in clickjacking attacks, you usually wrap a page the user trusts in an iframe, then renders invisible elements on top of the frame. So to ensure that your site doesn't get used in a clickjacking attack, you need to make sure it cannot be wrapped in an iframe by a malicious site. So how do you do this? By giving the browser instructions directly via HTTP headers, or in older browsers by using client-side JavaScript by frame killing. So X-frame options is a header that can be used to indicate whether or not a browser should be allowed to render a page in an iframe or frame or an object. It was designed specifically to help protect against it. Now, 3 permitted values for X-frame options. You have deny, same origin, and allow from URI. With deny, you completely deny of displaying an iframe wherever it comes from. Same origin, you allow iframes if they come from the same origin as the page itself. Now, allow from URI, this actually allows custom or user specified, not necessarily user, but yourself specified origins. So I said X-frame options, and I've also said content security policies, also probably user types. Let's see, user types. Google. Was it user types? Let's see. Not user types. Content security policy. New Google user. It was some sort of a types. Trusted types. Trusted types. Google. Trusted types. Yeah. Trusted types. Alright, so if you want to look more into that, let's see, trusted types, clickjacking. Do we have anything for that? Maybe. But regardless, so you use content security policy, which provides a broader range of protection than just the X-frame options. It is designed in such a way that website authors can whitelist individual domains from which resources like scripts, style sheets, and fonts can be loaded, and also domains that are permitted to embed a page. Now, you can use the frame ancestors directive for the CSP policy. You have none, which means that the page cannot be displayed in an iframe regardless of the site attempting to do so. Definitely look from this one. Frame ancestor self can only be displayed in a frame for on the same origin as the page itself. So this would be frame ancestor self. It would be the equivalent to the same origin for X-frame options. Deny would be, so X-frame options deny would be the same for frame ancestors none. Content security policy frame ancestors URI, this would be the equivalent of allow from URI. Now frame killing, this is for all the browsers to actually include a frame killing JavaScript snippet in pages to prevent them being included in foreign frames. So how would you actually do that? In this situation is self equals stop. So when the page load, this code will check that the domain of the page matches the domain of the browser window, which will not be true when the page is embedded in an iframe. So if you embed the page in an iframe, when someone tries to load that iframe, it will actually automatically trigger this script, which will check whether the domain matches. So the domain of the page actually matches the domain of the browser window, and if it not, it's actually going to kill the frame. So modern browsers don't have to do that. So if embedding is required in your application, consider adding a what list of domains so that you have control over where your content is embedded. Now, frame killing offers a large degree of protection, but it can be error prone. So I'm not actually really sure about the situations where it is error prone, but regardless. Now, code samples, frame killing in JavaScript. So code samples, this is actually for frame killing, and how to set up HTTP headers mentioned above in various languages and frameworks. So frame killing in JavaScript, as we've seen above, this is what you do. Now, when it comes to Python, you have to specify the HTTP headers, render to response. In this situation, you set actually the response is actually rendered to a template. Okay, the response is going to also have an object or maybe a key value pair, X-frame options. So you set the X-frame options to deny, for example, and you also set another key value pair that's also going to be rendered in the response, which is going to be the content security policy frame ancestors none. In this case, this is actually overkilling because you're saying the same thing in two different ways, but regardless. So it's probably the same thing in Ruby. You're adding X-frame options to deny, response headers, very similar to Python. In Java, as you can see, these actually go along the same lines, and in all of the situations here, as you can see, I'm not really sure if they have a reason to actually do it with X-frame options and content security policy on purpose, or if it's just for exemplification purposes, just to show how things are done. Now in Node, it's basically the same thing. You're creating, in the response, you're actually creating a header that's actually two headers, one X-frame options and another one content security policy, with the values to deny all frames, all iframes from being loaded. PHP, the same thing, except that you have another argument here which is false, which I do not actually know why is being used. And of course, if you need further reading, you'll just go to these two one from Stanford and one from Mozilla. So a study of clickjacking vulnerabilities on popular websites. Let's see when has this been published, if we can get an idea. We can see that they mentioned 2010 code in the references 2008, 2005, 1998. So this would actually be pretty old, as you can see by the way the websites looked back then. Quite pretty old. And the other one, content security policy. This is really important. Any application security professional should actually be very knowledgeable of CSPs, and of course from trusted types. This is a good place to start with from Mozilla. But if you go for content security policy, let's see which are the first ones to be shown. That one, the one from Mozilla. And then of course you have, maybe this is the official one. That's just about it. You could also look into the if you're more on the, I think it actually applies to both the defensive and the offensive side of things. So you should definitely look into the cheat sheet series from OWASP. Alright, OWASP, let's actually test ourselves. We're 11 minutes in, so pretty good. Which tag is typically used in a clickjacking attack to wrap another site? So we're having an iframe. What does a frame killing script do? Removes all iframes from a page. Which of the following header can help protect against clickjacking? So you have content security policy and X-frame options. Both of them. Or am I missing something? Which of the following headers can help protect against clickjacking? Content security policy and X-frame options. Both of them. Anyway, let's see if we do just X-frame options, because I only have the option to accept one. So frame killing script, clickjacking attack will wrap a page in an iframe. Removing iframes from within a page will have no effect. So in this situation, let's actually see if we try again and select the content security policy. What does a frame killing script do? That's what it does. It actually removes the frames, prevents a page from being wrapped in a frame. Well, let's see. So prevents a page, iframe, content security policy. Let's see. So in this situation, both of the answers were correct. Okay, I guess this was everything about clickjacking. In the next one, we're actually going to look into cross-site request forgery, or CSRF, or CSRF.